Okay, hello everyone. We are projecting for Innovate Future, and this is our current team members. So currently we are in the second sprint, and we've already finished the project initialization and tenant onboarding. Next, we will focusing on dashboard UI component implementation, local dev development, CAC and IAC, and etc. So this is next we will explore the details of the project initialization. Yeah.
Hello everyone, I'm YC. This is our project architecture overview. So as you can see, we have three major parts in our architecture diagram. One is front end, the other one is back end, and also the monitoring and logging system to ensure our reliability. So for the front end part, we use AWS CDN service called CloudFront to well distribute our traffic to all edges. And for the backend, we use ECS, which can help us to achieve auto scaling with no issue. And with the help of the application load balancer, it can also help us to achieve high availability. And for our logging and monitoring part, all the log coming from the backend and also the database will go into the CloudWatch, and then further syncs into Prometheus and Elastic Search. This is our final goal. We haven't implemented the monitoring and logging part yet, but also we planning to use the Grafana. It will make our logging and other telemetry data easy to access. And this is our production environment. But for our development environment, we use the API gateway to replace our application load balancer because it's serverless and cheap. It costs only when you use it. And that is our architecture overview. And next page, please.
Okay, this is the project structure for front-end development. We've organized the reusable components and type definitions to maintain code consistency and reduce duplication. The project uses a router-based architecture, making navigation and page management efficient. To simplify API interactions, we've implemented a centralized HTTP client for consistent request handling. The API logic is modularized, and utility functions are separately categorized for clarity and reuse. We've also integrated with unit test to ensure reliability and prevent regressions. For design, we use Shazam UI library, which provides a modern and customizable design system. Lastly, the code quality is maintained with ESLint and Prettier, and hotkey pre-made checks enforce high standard across the team. Next page, please. For our backend development structure, we use ASP.NET Web API for API development, and we also introduce 4-layer architecture for scalability and maintainability. The API layer handles HTTP requests and responses. The application layer manages workflow and business logic, and domain layer defines core business rules and entities. And the infrastructure layer handles databases and external services. We ensure reliability with unit tests for business logic in the domain and application layers, which can ensure robust and scalable functionality. Next, Vice will introduce more about how to expose our backend services.
Okay, so As we all know that during the good old days with monolithic servers, there's a powerful HTTP web server called Nginx. You use it to take care of all the proxying and TLS terminations and other cool stuff. But for the cloud native solutions, AWS provides a similar service called API Gateway, but with more functionalities. We here only introduced API Gateway because we haven't deployed our production environment yet. So in our development environment, we are using the API Gateway. So the API Gateway with more functionality. So what's more, it can help you to customize and delegate the authorization out of your backend service with custom authorizer. And it also supports VPC link to allow you to proxy traffic to your private resources with the help of Cloud Map, private DNS service. And next page, please. So for our so like I mentioned before, you can integrate your custom authorizer into your API gateway. So here we implement our custom authorizer to delegate the authentication flow and also part of our authorization. So we try to use the AWS Cognito service to take over the entire auth flow. So one big benefit of moving the auth flow out of our backend service, it is that it can help you service to better scale out, and separation of responsibilities can also ease the deployment overhead and make your API server solely focus on the business logic. Can you click on the login flowchart? So here is our login workflow. So as you can see, user can log in via the Cognito hosted UI. And after they input their user credentials, the Cognito will then redirect back to our front end, but with a authentication code. But that authentication code is not enough to authorize you to access our backend API. So the front end then use that authentication code to send that code to our Lambda to exchange a access token. And then after that, user get the access token, and the access token will be set to their cookie with the help of the Lambda function. And then the login workflow is done. Can you go back? And the other important authentication flow is the user registration. Can you click in that invitation flowchart? Sorry. Click the invitation flowchart. Yeah, okay. So for the invitation part, also you can call it registration part. So from the inviter perspective, after you log into our system, you have the access token, and then you use that access token to access our user invitation endpoint, which is written in a Lambda function. And the Lambda function will then forward the user's request to our backend to see whether your form is valid and whether we can create that user. If that user is valid, our backend will create that user first, and then return the valid response to the Lambda. And then Lambda will forward the request to the Cognito user pool, and then the user will actually create it in the Cognito user pool. And after that, we will have a callback function after user's confirmation from the Cognito. And the Cognito will then call a Lambda function to update that user status in our database to make our database user and Cognito user pools to synchronize. And can you please click back? So This is our four important Lambda function to take care of all the authentication workflow. The first one is for invitation. The second one is used to verify user's token from their cookie. And the third one is used for the token exchange. And the fourth one is the callback function after user confirm their registration. Can you click once? Yes. So after user invitation, basically the invited user will get an email with a temporary password. And you can see in the Cognito user pool, the user will be created. And also we will have that user in our backend database. And next page, please.
And this is the schema diagram designed for SaaS platform. To make it clear, we separate it into two core parts. The SaaS tenant and tour management. As you can see, the yellow one, this part is for user management, and for the tour management is the green part. And our latest update mainly focus on SaaS tenant, which includes organization details, user details, and the user profiles. Our schema allows third-party identity provider by linking the providers subject to the user schema. For example, Cognito SAP UUID. User can also switch between profiles to act on different roles if they have multiple profiles. Next, please.
Next, we will exploring the details on the tenant onboarding.
Okay, my name is Raymond, and I'd like to talk about API design. Our API documentation is managed using Swagger, making the collaboration between the front end and back end straightforward and efficient. The API revolves around the core modulars like organizations, profiles, roles, and users. Each modular serves a specific purpose. The organizations modular supports creating, retrieving, and updating organization informations. The profile modular handles updating and retrieving user profile data. The roles modulars allows querying roles by name and/or an ID. The users modular facilitates the user's creation, retrieval, and updates. Next page, please. And this collection of the pages showcase the front-end design of our organization platform. So from the left, we can see this page serves as our platform homepage. And at the right, this is the detailed view of our past event. And at the central, the Welcome IFA pages is the Contact Us page. Next page, please. In our project requirements, we suppose we have 5 types of user groups corresponding to 5 different roles like students, parents, teachers, organization administrators, and platform administrators. Each role has distinct functionalities and requirements. So we designed the different dashboard styles and tolerate their specific needs. This ensures that each role has an interface that aligns with their use cases while maintaining the consistency and efficiency across the platform. So next page, please. To reduce our development effort, we adopted a modular approach by creating a library of reusable UI components. Many of these components reflected in our tickets, such as the breadcrumb navigation, table list, model of link-wise user, and avatar, a drop-down menu, and something else. By combining these components, we can efficiently build interfaces for different roles with ensuring the cohesive look and the feel across the system. And let's turn back to YC to talk about next page.
So to improve developers' working experience and also to ease the inconsistency while development, so we containerized basically everything. So we containerized our app and DB service, as well as our migration task. So as you can see, we have 5 containers. The task containers, which is used to run tests, and the migration service, which is used to run our one-time database migration job, and the API service used to run backend API. And we also have a Postgres service to act for our database, and for easy tests and development, we also deploy a DB client, which is a very lightweight one called pgadmin web, which is a web app to allow developer to see the changes in the database. And next page, please. And if the developers want to task as a group, or want to have a unified online environment, we have a ECS deployment also. So you can see it's pretty much similar to our Docker Compose deployment locally. And we have API and DB service run in the Fargate service, which have API and DB container reside in a private subnet. We have a migration task runs in a Fargate task, which relies on our DB container run in the Fargate service. And we also have a pgadmin service reside in public subnet, which can allow direct public access. And with the help of Cloud Map, all these resources can achieve interconnectivity and with ease. And basically, our service reside in the API and DB service reside in the Fargate service will register themselves to the Cloud Map, and then the migration task can use that private DNS entry in the Cloud Map to access our DB to do the migration. And next page, please. So when we talk about CI/CD and automation stuff, there's always an option called Jenkins. But to make it easy and very reusable, so we introduced Jenkins with Ansible and Terraform to achieve auto deployment and auto configuration. And next, Mark will introduce how do we set up our Ansible with Jenkins. Next page, please.
Hi, thanks, YC. With Ansible, we have implemented an automation configuration for the CI/CD server. Use Ansible roles for flexible orchestration. Introduced needed roles to each playbook. We have designed the roles including Base, Java, Jenkins, 30-volt, Nginx, and Docker, with structured tasks and invocation handlers. The roles can be used in both Docker container and also in Cloud VM. It is a fully automated setup, including predefined Jenkins plugins and node configuration. We have also adopted Ansible Vault for Jenkins user credentials initializations. And also we have used Ansible Lint for best coding practice, standards, and optimize task definitions. Also, we have wrote tests for each role. Configure separate groups for master and worker nodes, so we can set up a standalone Jenkins and also a Jenkins cluster, and automatically provision worker and register nodes on the master. If we have a cluster, we have also configured to scale down master node number of executors to 0, separated and parallel job tasks for slave nodes. So next page, we will introduce the Jenkins and the Terraform.
Thanks, Mark. I'm Jason. My part is about Jenkins setup with Terraform and Ansible integration. Firstly, for the Terraform structure, we have the main file for the main code and the configuration, and also we have variables file for the input variables such as instance type, access key name, and also the key path. And also we have output file for the recording of EC2 IP addresses. And also we use AWS as a service provider. And for the security group, we allow web traffic on 880 on the master node and allow only TCP connection on port 22 from master node in slave security group. And for the Ansible integration, we use local file resource in Terraform to automatically create an Ansible inventory for Jenkins server in the inventory.ini file. And also we use local exec in Terraform to wait for EC2 fully start and then invoke Ansible playbook for Jenkins configuration. And for future steps, we are going to create an S3 bucket for Terraform state file. And also we are going to use DynamoDB for state log to avoid the state conflict. And thank you. And the next part is for Henry.
Thank you, Jason. Hello, I'm Henry. So this slide illustrates how Route 53, AWS ACM, and the ALB work together to enable secure access to Jenkins. Starting with Route 53, it acts as our DNS, mapping domain names to the ALB. AWS ACM is responsible for mapping SSL certificates, ensuring encrypted communication for our domain. Finally, the ALB handles traffic routing and securely forwards it to our Jenkins server, running on EC2. Together, these components simplify HTTPS setup, automate certificate renewal, and enhance the security and reliability of our Jenkins environment. So, next page, please.
So this is our future plan. We've already finished the project initialization and tenant onboarding, and next, due to the current scope changing, we will preliminary focusing on the authentication and authorization due to the failure of incognito. Yep. And for better understanding, we've already we've prepared a demo. Yeah, so I can play this now. Thank you for watching our midterm demo. That's all.